Hello, everyone. Welcome to this live stream. Thank you all so much for joining us today. It's a pleasure to speak to you here and to continue this kind of second session to the second kind of series that we have. Let me share my screen here and let's get started. Thank you all so much for joining us today. It's a pleasure to be here with you and continue this kind of a second episode of this three-part series. In today's episode, or in this kind of series, it's all about jump starting into AI. So I will kind of be taking you through like the fundamental concepts or the kind of foundations that you kind of need to know to build kind of a framework for getting started into your AI journey, whether it's you want to get started with building your own AI project, or maybe you want to kind of shift into this field but don't know how. This kind of series is for you. Very excited to kind of be continuing on this series with you all. That being said, let's go to the code of conduct. So as you all know, this event is part of our Microsoft Reactor code of conduct, which means, we're all here to learn. So let's be as obviously as friendly as possible and be all always considerate and open to all questions and viewpoints. The chat box is, right there. So please feel free to kind of ask any questions and I will make sure to answer them either, in the middle of the session or maybe even at the end. That being said, let me kind of introduce you all to myself. If you have not been here before, or if you haven't, attended any of the events that I've done yet, my name is Hadeel and I am a regional cloud advocate and data analytics engineer at Microsoft Reactor, Middle East and Africa. So basically, part of what we do as regional cloud advocates is basically I am very passionate about kind of sharing with you all the kind of knowledge and learnings that I personally have learned, throughout, my tech journey. So I'm very passionate about kind of, talking about topics and exploring topics in tech, specifically in data analytics, data science, AI, machine learning, Internet of Things, as well as kind of exploring other fields as well, and technologies and platforms and, tools and solutions to kind of tech kind of problems. So, we are part of the Microsoft Reactor Middle East and Africa meetup group. So if you would like to kind of stay up to date with our latest events to kind of see, where you can, see what your next event could, something that you could be interested in, whether it's maybe, where my next session will be, your best bet is to kind of join our meetup group. So just search www.meetup.com/Microsoft Reactor MEA, Microsoft Reactor Middle East and Africa. Make sure to join our group just to kind of stay up to date with all the latest events. It's not going to be only me. We have other experts and professionals in the field and other cloud advocates as well, who are always talking about different topics from beginner to even advanced kind of levels. So whatever you really want or you're looking for, so if you're looking getting to get into to learn more about AI, you definitely can find events there. If you're looking to learn more about Power Platform, you can find some events there and so on. So make sure to join us on our meetup group if you haven't yet. That being said, let me go back to the stream just to check, if you have any kind of questions and such. So please let me know where you are joining us from. I am, here based in United Arab Emirates, Dubai specifically, and that's where I am from. Please let me know, to our online audience where you are joining us from. I would love to kind of, get an insight of, where everyone is joining us from on this online community. Hi, everyone. I'm seeing the comments and all that stuff. So let's go back to the slides and get started by seeing what our recap for the first session was. So very quickly in the first episode of this three-part series, what we did was we learned all about AI. We went all the way back to kind of we talked about the history of AI and how AI really came about. We then kind of understood what AI is all about, from its definition, its keywords, its key terms, it's the core concepts kind of that build what AI is made of. After that, we were able to distinguish between the different types of AI. Then we learned all about the applications of AI in today's world. So since artificial intelligence is being applied and being used kind of really in every single sector there is out there, from transportation, education, healthcare, the healthcare sector you have, in finance, in logistics, in transportation, All those fields, we gave examples on where you can see, applications of AI actually being used in our daily life. We then differentiated between the terms of artificial intelligence, machine learning, and deep learning. So you have artificial intelligence, you have machine learning, which is a subset of AI, and you have deep learning, which is a subset of machine learning. And they're all kind of correlated to each other, so we kind of were able to distinguish between those terms. And then lastly, what we did last time is we briefly explored the different types of machine learning algorithms that we could use in AI projects. Today, what we will actually learn in this second episode is we will learn all about the AI programming cognitive skills. We will be able to distinguish between the different categories of artificial intelligence. We will explore machine learning concepts in more depth, giving kind of more insights on the term of machine learning, because machine learning and AI are they come hand in hand. Obviously, AI depend on machine learning algorithms so much. So it's very important for us to kind of understand all about machine learning and how it's applied, so you can kind of apply it to your AI project. We will explore the most popular types of machine learning algorithms in more detail. So since any kind of data science project or any kind of AI project that you want to kind of start building, any kind of step that you really take, it really kind of heavily depends on machine learning algorithms. So we're going to explore some of those, since you have a huge broad sea of machine learning algorithms out there. And I'm also going to at the end show you a Microsoft Azure cheat sheet for all the machine learning algorithms and how you can select the best one for based on what you're looking for. The last thing we're going to talk about today is I'm going to give you, as a Regional Cloud Advocate, my best tips and advice on how you can get started into getting into the field of AI. If you're a beginner, if you're a student, if you're someone who's looking to shift into this field. So this is our agenda for today. And with that being said, let's get started. So last time we kind of talked very briefly about, the history of machine learning and AI and how it all kind of came about from the 1950s to basically where we are today. There was like kind of a lot of scientific research, and there was a lot of kind of testing and approaches, and they were kind of trying to do things here and there and trying to test to see if a computer will act like humans, or try to mimic human behavior and such. So they came up with kind of chatbots along the way, and then they kind of the research kind of stopped because there was no compute. And then we had the compute come back into our homes, and we had even more data and such. And then we can say that we have gone through kind of the age of invention, and now we are in the age of actually application with all these new technologies that we have, from data science, machine learning, deep learning, neural networks, even convolutional neural networks. You have natural language processing. So you have all these new technologies and tools that are actually kind of taking over and being actually applied in every single sector there is out there. So this is kind of how this kind of the tech journey of machine learning kind of started. But where is AI actually today? Today, artificial intelligence is actually being applied in every single part of our lives, even if we don't realize it. So, for example, we are all obviously familiar with Siri or Alexa, the chatbots. So, obviously, when you ask Siri to close the blindfolds, to open the windows for you, to bring you a cup of coffee, you are actually interacting with a chatbot or an AI enabled kind of system. So basically, with Siri, there is it's kind of trained by you give it some input, it will analyze that input by being trained and all that stuff, and based on that, it will give you the output. So this is where we are today. AI is being applied into every single sector there is out there in every part of our daily lives. And we can see so many examples there is around us. So, for example, you have self-driving cars like Tesla. We have obviously customer segmentation. You have fraud detection. You have spam filters as well. We have Google Maps, for example. So, obviously, back a few, maybe let's say like 20, 30 years ago, we did not have they did not have phones, and maybe they did not really have Google Maps. Okay. So if you had like a new location that you would go to, people usually would kind of depend on the signs in the streets, or which are a few kilometers away. So you would not know if there's ahead of you like a roundabout, or there is like a congestion, or maybe the road is closed. But now, thankfully, with the AI enabled kind of tech, which uses Google Maps actually uses real time data. to give you the best accurate results for to show you which is your best route to go, or where, for example, if there's like congestion on the way, so you can avoid that road on that specific timing, and so much more. So this is where we are today. So we explored obviously the different keywords that come with artificial intelligence, which are very important. We have artificial intelligence, machine learning, and deep learning. So very quickly, for those who are not familiar, we have artificial intelligence, and that is like the big umbrella. So AI is basically the ability of a computer or a machine to mimic human behavior. So basically, we train AI systems to kind of literally do what we as humans do. Machine learning is a subset of AI, and machine learning basically, it is just like its name, it's a machine that basically learns. How does it learn? It kind of learns and improves from experience by giving it kind of past data, historical data, by training it and such. And this is where you use kind of scientific and mathematical computations to help the machine learn. Then we have the deep learning. Deep learning is kind of, we go a bit deeper. Deep learning is a subset of machine learning, and deep learning is actually uses more complex machine learning algorithms that are all about deep neural nets that are used to train a model. So this is kind of the umbrella of AI and the key terms that fall underneath that. So here we have a table that kind of summarizes, the definitions of each AI, machine learning, deep learning, and neural networks, and what each one kind of uses and where each one is used. So, for example, artificial intelligence is usually used everywhere. So, for example, you have in Siri, we mentioned Tesla, self-driving cars, we have Google Maps, we have even recommendation algorithms, like, for example, as well, you have Netflix. So Netflix gives you automatic recommendations based on what you previously searched for. So these are all kind of examples of where artificial intelligence is used. With machine learning can be used in traffic predictions. So obviously, since machine learning uses real-time data and such, it will help you predict traffic, at that specific time in that specific area and such. Or even social media with people you may know suggestions. So based on historical data, it will use machine learning algorithms to kind of help you, help recommend to you, people you may know and you might want to be friends with. Deep learning, this is where we go a bit deeper. And this is kind of more, used in also self-driving cars as well, visual recognition and visual assistance, and so much more. With neural networks, it is kind of all similar to kind of the human neural system. And this is where you can see it more in kind of social network net filtering, product design analysis, and so much more. So this is kind of just to give you an overview of these kind of different terms. Now, today we're going to talk about kind of the three cognitive skills that AI programming focuses on. So, we always say that the AI, the main definition of AI is to mimic human behavior, right? But what does this actually mean? So, if you want to actually mimic human behavior, we need to know or have the abilities of learning, reasoning, and self-correction. So, AI programming kind of focuses on three cognitive skills. With learning, it's just like the learning processes is just like its name. It's you basically acquire information and data to turn this data into actual actionable information or insights. So here, this is where you kind of use algorithms, that help you to complete a specific task. With reasoning processes, they kind of are all about choosing that right algorithm to help you reach the desired outcome that you are looking for. And self-correction processes are just like its name, they self-correct themselves. So this actually kind of works by fine-tuning the algorithms and ensuring they provide the most accurate results possible. So if you're not kind of familiar what algorithms are, they're kind of mathematical equations or computations that are used in AI systems to help train the machines and such. Now, when it comes to kind of the goals of AI and why AI is kind of being used, researchers and programmers and experts kind of have elaborated the goals of AI to kind of six different points. So you have the first one is kind of logical reasoning. Now, with logical reasoning, it's just like its name. So you're given kind of a set of data, information, or facts to deduce other facts by reasoning logically. هاوي بس سكري الشباك. Sorry. So we're using, the goals of AI is researchers and programmers have extended, the goals of AI to logical reasoning. So basically, you will use a given set of facts or data to kind of deduce other facts by reasoning logically. For example, let's say you are facing a problem in the office or anything. How would you kind of address that problem? You are basically using available facts, logical reasoning skills. Knowledge representation is the second one. With knowledge representation, you are basically kind of presenting real world information in a form where a computer can kind of process and understand, just like how a human would handle real life tasks. So that's the knowledge representation. With planning and navigation, it's kind of where you kind of enable a computer to move from a specific point to another point. So the best example for this is, like Google self-driving driving Toyota Prius, which moves obviously from one point to another. Natural language processing, this is a very common one that we always see in AI, and it is all about setting up computers that can understand and process language and speech and basically anything that has to do with text and such. We have perception, and perception is all about perceiving how the world through, how we see the world, how we hear and touch and smell. So all our kind of senses. And the last one is emergent intelligence. And emergent intelligence is basically intelligence that is not, specifically programmed, but it kind of emerges from the rest of the specific AI features. So this kind of focuses more on emotional intelligence and moral reasoning. So these are kind of the six goals of AI that, the programmers and researchers have kind of elaborated and come to. So when it comes to the types of artificial intelligence, they can be kind of, we can say that they can be kind of divided into kind of two categories. So based on the capabilities they have or based on functionalities. Let's talk about the first section, which is the capabilities. So based on what, these types of AI can do, we have narrow AI, general AI, and super AI, which we will cover briefly in the next slide. And based on the functionalities, you have different types of AI, such as reactive machines, limited theory, theory of mind, and self-awareness. Let's explore those kind of types of AI a bit more, in depth. So, based on capabilities, you have narrow AI, general AI, and super AI. The best or the easiest way to kind of, tell you what narrow AI is basically dedicated for only one task. So you give your AI system to do only one thing, just really well. So, for example, maybe the best example for this is, like those robotic vacuums that we have roaming around. They can only vacuum your whole house, but very, very well. The next one is the general AI, and general AI basically performs just like a human. So you're basically teaching your AI or your robot or computer to perform just like how a human does. And when it comes to super AI is basically when machines are kind of more intelligent than humans. So we have not reached that kind of super AI level yet. I would say we are more from the narrow to kind of general AI now, but super AI is kind of taking it to the next level. When it comes to the functionalities, AI can actually be categorized into four types, beginning with kind of task-specific intelligent systems and progressing to even sentient systems, which don't exist yet. So let's look at these kind of categories, which are very important to kind of know. So the first type that you have is reactive machines, and we're going to explore actually in the next few slides each one kind of separately, and even giving you examples of where you can see each one. So reactive machines are basically systems that have no memory and are basically very task specific. So they only focus on doing one task very well, but they don't have any memory. Type 2 is limited memory. So you have some memory, but you are limited. So it uses past experiences and even historical data to help predict or inform future decisions. The third type is the theory of mind. With the theory of mind, you're basically kind of using human intelligence to kind of basically imitate human intentions and even predict behavior. And the last type we have is the self awareness. So this type of AI actually does not exist yet, but basically it's kind of, where AI systems have a sense of self and it gives them consciousness. And machines with self awareness understand their own current state. As I mentioned, we have not reached this stage yet. Let's explore each type even more. But before we do that, let me just go back to the stream just to make sure we don't have any questions. I am looking now at the comments actually because I have only one monitor. So I see that we have people from India. Hello. We have people from Dubai, UAE. Hi. You are, obviously my neighbors. And we have another also person from Dubai, UAE. I see also, different people. So it's very lovely to be joined by all of you. So yeah, um, now let's go back to the different types of AI. Reactive machines. So with reactive machines, let's kind of explore that even more. With this type of AI, obviously, as I mentioned, it doesn't use past experiences or historical data to determine future actions. So because it doesn't use past data, it only works with present data. And it basically would kind of depend on present data to perceive the world and react to it. Obviously, with reactive machines, they're only kind of task oriented, so they deal with specific tasks, and they don't have any kind of capabilities or abilities to do anything beyond those tasks. The best example I can give you is actually we have an example of Deep Blue. So in the 1990s, this Deep Blue is kind of like the chess program which IBM created, and it actually, obviously, since it's AI enabled, it actually beat Gary Kasparov, who was actually the chess mastermind in the 1990s. Deep Blue was able to kind of identify pieces on the chessboard by being trained and also making predictions. But because it has no memory, it can't use past experience to inform future ones. But it's still, with the AI kind of, tech enabled experience, it was still able to beat the mastermind, the chess mastermind himself, Gary Kasparov. So this is an example of where you can see reactive machines. Limited memory. So with limited memory, here you actually have past data or historical data that you use to kind of help you make decisions and help you kind of make predictions in the future. So they can use past data for a specific period of time, but it can't kind of add to the library of experiences. And the best example of where you can see limited memory is obviously in self-driving vehicles like the Prius or maybe even Tesla and so much more. With limited memory, so for example, let's take the self-driving vehicles example into consideration. With limited memory AI, it kind of observes how other vehicles are moving around them at the present and even as time passes. Then this data will kind of be collected and added to the statistics of that AI machine, such as maybe traffic lights, congestions, lane markers, and so much more. Then they will be included when the vehicle decides when to change lanes, avoid cutting off another driver, or hit a nearby vehicle. So this is how kind of you see limited memory, being used in self-driving vehicles. With theory of mind, this is kind of actually used, or it exists only kind of more as a concept. But the best example of theory of mind is Sophia. Sophia is a robot who is, who has been AI kind of, let's say, trained, and it has. Sophia was built to have cameras in her eyes, computed obviously using machine learning algorithms that allow her to actually see just like a human sees. So when she actually sees humans, she's able to detect faces, she's able to kind of sustain even eye contact with the humans and even follow faces. So basically what theory of mind is all about, it's all about kind of that human emotions and an environment where you can kind of teach your AI to alter feelings and behavior. So basically act like how a human would see and feel. This kind of AI is not actually fully complete yet, and it only exists as a concept as of now. Self-awareness AI is obviously the one that does not exist yet. It only exists hypothetically. So with these self-awareness AI, they kind of understand the internal traits, the emotions, the states and conditions, and even perceive human emotions. Now, it is kind of known that these machines, once they actually exist, if they do exist, they will be even smarter than the human mind by kind of, a lot of stages. But this type of AI will not be able to understand and evoke emotions in those it kind of interacts with, but it will still also have emotions, needs, and beliefs of its own. So just like a human being has their own, this kind of AI has its own, hence its name, self-awareness AI. So these are the four types of AI that fall under the functionality kind of, category. Let's kind of move on into AI and machine learning. So AI is all dependent on, obviously, so AI is as we mentioned, it is the ability of a computer to mimic human behavior. And to mimic human behavior, you kind of need to use mathematical equations and kind of, these algorithms and computations that allow you to find the relationships in data, to discover hidden patterns, and to help you train models to replicate some aspects of human behavior based on the historical data that you feed it. Now, today, in this point of time, we kind of consider AI to be a very powerful tool that helps us extract patterns from the data and to apply those patterns to solve new problems. Let's talk more about machine learning. So, with machine learning, you are kind of using machine learning in AI to help you kind of make predictions or make better decision making without being explicitly programmed to do so. So this is why we use machine learning algorithms. Because machine learning algorithms actually use historical data as input to help you predict the new output values. So, for example, you have, as we mentioned, the chatbots like Siri. Siri will take input from you, so you will feed it with data. It will analyze that data, and based on the analysis, it will give you an output. So, this is how kind of a machine learning algorithm would actually look like. So, the machine learning is actually kind of the most popular technique of predicting the future or helping in decision making or classifying information. So anything that you really need to do, machine learning is the one that will kind of help you, with the use of algorithms, make necessary decisions. Now you might ask, but how are machine learning algorithms actually trained? So the easiest answer is over historical data. So using data. So machine learning algorithms are trained over examples or instances through which they learn from previous experiences or historical data and analyze that data. So based on what you feed it from previous data, it will be able to learn from it and kind of build and make decisions on its own. And the more data you feed it, the better. So therefore, as it trains over the examples or over the instances that you feed it, it will be able, time by time, stage by stage, to kind of help identify patterns over time, and even help you make predictions about the future or help with your decision making process. We will obviously talk about this more just so you can have an idea of how this actually works. Now, the use of algorithms in AI is actually huge and very fundamental. So no AI project is complete without machine learning, because the use of machine learning algorithms are used to kind of help with analyzing the data. They even gain information and insights about the data. They understand that data, and based on what you kind of give it, it will help you make the prediction or even create an outcome from it. So by using large amounts of data and feeding kind of the model that you have, it will help you. It should have the like possibility to learn how to complete a task from A to Z as soon as you give it more data, so it will be trained over and over again. So it's just like a process, just like how you have a newborn and you teach them to how to eat or how to kind of walk or take their first steps. It's just kind of the same for a machine or for a computer. So here we have just kind of a process just to kind of help you understand how it would look like. So let's say you have a computer which is works as an ordinary system. It's a normal thing and all that stuff. But with the addition of AI and the use of machine learning algorithms, this you will be able to learn, predict, and improve from your decision making kind of process by the use of AI and machine learning algorithms. So we can live without AI, but the use of AI and machine learning just makes things more faster, more efficient, and more effective, and even more time efficient as well. So instead of us humans, doing a task like data entry, for example, for maybe 10,000 hours plus, a machine learning algorithm, like an AI trained machine, would actually be able to do that task in a matter of minutes if it's trained. So this is why the power of AI and machine learning is very important, and it's actually being applied and used in every single sector or company or organization there is out there. Now, when it comes to the machine learning process, it's very kind of important to kind of understand or have an idea of the kind of the steps that go through a machine learning process. So let's say you're a data scientist or you're a data analyst or you're someone who wants to build the first, AI project. So the first thing you will do is you will get your data set that is based on your objective, what you want to do, and by finding your relevant data, you will start by preparing it for analysis. The next thing is you will choose the right learning algorithm based on obviously your objective. So with machine learning algorithms, we will be talking about this more in the next few slides. the main There are like many kind of factors that lead you to choose which machine learning algorithm is most suitable for you, or what you're looking for. So we will look at an actual cheat sheet that will help you kind of understand how to choose what. Then you will build a model based on the chosen algorithm. After you build that model, you will train that model using the data set you have. So you will have some data set that you will train the model on, just to see how it works, and you will start kind of feeding it and teaching it and feeding it and teaching it and revising it as needed. And then you will run the model to kind of test it to see how it actually worked after you trained it, to see if it actually meets with your objectives in number one. So this is how very briefly the machine learning process actually works, just to give you a quick idea. How do machines learn though? As we mentioned, machines actually learn from input data, so from the data that you feed it, and from previous past experiences and historical data, and using optimization methods. Now, you might mention, okay, Hadeel, I have a machine learning model. How do I know if this machine learning model is actually good and it's actually working? There are two kind of major aspects that you need to look at to actually, measure the quality of the model. So the first one is the quality of the input data, and the second one is the model choice itself. What do we mean by the quality of the input data? So the best kind of the first step, obviously, once you want to start with any project, data science, machine learning project or such, is you need to gather the data. And once you gather the data, you need to look at the quality of this data. The data needs to be clean. So usually, as data analysts, as a data analyst myself, we usually receive data sets that come, for example, in the form of Excel sheets or Google Sheets, and they are obviously divided into categories or into tables in an Excel sheet. So let's say we have customer data for let's say supermarkets. Okay, so you have a supermarket table, and you will have, for example, the name of the customer, the time when the customer arrived, what products the customer buys often, and, for example, the prices of the products that they always buy. So once you have these kind of fields, sometimes once you receive this Excel sheet which has this data, you will see some missing information. You will see some information that does not make sense, maybe, or is not related to the data set. And we call this low quality or messy data. So this is actually gone by a very famous saying in data science or machine learning, is garbage in, garbage out. So if you have bad data, you will have bad results. So you need to make sure to go through the data cleaning or data processing step. Make sure that you kind of rearrange in specific steps this kind of quality data. Make sure it's clean and it's ready to go before you actually before you actually apply machine learning algorithm, and it moves on to the data processing step. So obviously it's very important to look at the quality of the input data that you feed the model, so you can get great results or great outputs. The next kind of aspect that depends on the quality of the machine learning model is the model choice itself. So as I mentioned, we live in a world where we have a lot of tech and all these new machine learning algorithms that have come up, and every single machine learning algorithm is actually based on specific factors or based on the goal that you want to achieve. So if you want to predict something, you want to predict, for example, the sales of your products in the next few years, for example, you would have to use a regression algorithm. If you want to classify, for example, if this kind of patient has cancer or not, you're classifying something into two classes, you would use classification algorithms. So we will talk more about this, but it's very important to know how to use the best machine learning algorithm. And for that, I'm going to actually be showing you a machine learning kind of algorithm cheat sheet that will help summarize for you, how to select the best machine learning algorithm for your model. And it's very important to know that the better the machine learning model that you have, the more accurately it can find features and patterns in your data and help with your decision making and predictions as well. So the more data, the better. Now, there are 4 key steps that we can actually look like when we want to create a machine learning model. It's very important to kind of understand how it all works, just so we can have an idea of, when you want to start building your first, when you want to create your first machine learning model, what steps are very important or vital to take. The first one is to choose and prepare a training dataset. So with training data, you actually have data sets, obviously, which is related to your objective. So you will take this data set and you will kind of split it into a training and testing data. Training data is basically you are kind of, it takes most of the time for all data analysts or data scientists to do, because you are basically kind of teaching your model from A to Z to do exactly what you want it to do when you feed it new data to give you the outcome that you are looking for. So with training data, we use sometimes we use labeled data, or sometimes we use training data that could be unlabeled. For labeled data, data could be divided into a training data set and a testing data set. So this kind of helps obviously with we usually scientists actually agreed to take to split the data sets into a ratio of 80 to 20. So 80 being 80% of the data set is split into training and 20% is only gone to testing. Because you are teaching, you need to kind of revise and go over your model over and over again to make sure it understands and actually is trained from A to Z. So after you choose and prepare your training data set, you will select a suitable algorithm that you apply to that data set. The type of machine learning algorithm, obviously, you choose will depend on a few factors. So whether the use case is prediction or classification. So or even clustering or dimensionality reduction. So there's a lot of kind of factors that you need to look into. Is it a prediction problem? Do I want to predict the number of houses or stock prices in the next few years? Do I want to classify something into, for example, cats or no cats, for example? Do I want to, if I have clustering, and so much more. The next kind of aspect or factor we have to look at is how much data we have in the training set. It's very important to look at the data that you have in the training set. And as I mentioned, the more data you feed your model, the better it will give you and it will learn from the results. The nature of the problem the model seeks to solve as well is very important. So obviously, you need to kind of look at the problem that you are looking to solve, your objective, and what your goal is by the end of it. So, for example, when it comes to prediction or classification use cases, you have specific, obviously, algorithms that fall under prediction and under classification. So for prediction, you would actually use regression algorithms such as logistic regression. With unlabeled data, for example, with unlabeled data, you would use clustering algorithms such as, you have k-means or even the nearest neighbors. And so much more. So really, you need to kind of get an overview of what classification problems are, regression problems are, clustering problems are, and the algorithms that fall underneath each kind of category. And this is what we will be looking at. The third step is to train the algorithm to build the model. So you will start training that machine learning algorithm to actually help with building the model. And this is done by tuning the model variables and parameters to help predict accurately the appropriate results that you're looking for. So this is kind of, used by, obviously, when you feed more historical data and you start training it, you will start using a variety of optimization methods that will kind of help and depend upon the chosen model. And this is where kind of the machine actually learns from the data that you give it with little to no specific direction from actually us as humans. So you will train the algorithm to build the model. And the last and fourth step is to use and improve the model. So you will see the results of the model, but how to see the results and to make sure that your model is actually working, is it working correctly, you will actually feed your model new data and to see if it's actually giving you right results or not. And by that, you start improving its effectiveness and accuracy over and over time. And this kind of also, for example, let's look at a machine learning model for self-driving cars. It will ingest real world information such as traffic laws, road conditions, congestions, objects, and so much more. So this is kind of how the steps are for a machine learning model. Let's go and dig deeper into the types of machine learning algorithms that we have. So as I mentioned, we live in a world where AI is being commonly used and in all projects, in all businesses, organizations, and it is heavily, they all kind of heavily rely on it very frequently. So underneath AI, we have the machine learning algorithms that are very important. It's very important to know that machine learning algorithms are actually classified into three kind of categories. So you have supervised learning, unsupervised learning, and semi-supervised and reinforcement learning. Supervised learning is basically task driven. So it is used to classify something or predict a value. So it does a specific task for you. So for example, if you are in the financial sector, an example of supervised learning that you would see is to detect fraudulent transactions from a list of credit card transactions. When it comes to unsupervised learning, it is the data that is unlabeled, which means it is mostly data driven. So you kind of use, it's used to kind of find patterns in the given data that you have. So here you're kind of asking the machine learning model to process the data from which you can then kind of draw your conclusions and be able to make your decisions based on it. With unsupervised learning, the best example is customer segmentation based on kind of the spend data. You have semi-supervised learning. It's a combination of both supervised and unsupervised learning. And the last one is reinforcement learning. It's basically it's the learning by mistakes or by trial and error. And this is the closest to how us as humans learn. So obviously, us as humans, we only learn by trial and error. So this is kind of the best and the closest way to how we learn. For example, giving personalized recommendations on streaming platforms like YouTube, Netflix, Google, and so much more. So these are the three machine learning categories that are fall underneath the algorithms. Now, in supervised learning, it's important to know that we divide the data between training and testing. So as I mentioned before, once we have a data set, we need to feed our model, most of the data will go to the training for the algorithm, and most of the data, the other part of the data will go for the testing data to the model. So we will feed the training to the algorithm so it can learn from it and it's kind of take on its path and produce a model for you. And then you will take the other part of the data that you have, which is testing, and you will test that to the model to get an idea about the performance and how your model is actually working. So as supervised learning is actually used to classify something or predict a value, there are two types of algorithms for supervised learnings. So with supervised learning, we have classification models and regression models. Let's look at each one separately. Classification is just like its name, so categorizing data based on classes or categories. So, for example, you want to predict if a transaction is fraud or not. You want to classify if an email is spam or not. You want to kind of see if a patient has cancer or not. So, anything really that has like a yes or no kind of a class that falls it underneath, like a pass or fail or anything that has to do with classes, this is a classification problem which falls underneath the supervised learning. When it comes to regression problems are all about predicting numbers or predicting numerical value. So the best example is you want to predict the number of sales of your ice cream in the next few years. You want to predict the sale price of a house. You have a house price prediction. So anything that has to do with predicting or anything that has to do basically with numerical predicting or knowing what a numerical value is. So this is classification and this is regression. Here we have a table that kind of summarizes machine learning, the types of learning that fall underneath each, the different types of obviously problems or algorithms that fall between underneath each. And then, for example, if you have a classification problem, you can use the following. You can use a naive-based classifier, you can use decision trees algorithm, you can use support vector machines, random forest, k-nearest neighbors, and such. So this is kind of just an overview just for you to get an idea on the different kind of, machine learning algorithms that we have. And as I mentioned, I am yet to post the machine learning cheat sheet for you just to kind of help you understand how you can kind of differentiate between each one. So let's talk about, the most popular machine learning algorithms in supervised learning. When it comes to classification, so, having or separating your data into classes, you have the most popular algorithms used are logistic regression, naive Bayes, and decision trees. Let's look at each one. And then we have for the regression problems, which are used to predict a continuous quantity or a value. Linear regression is mostly used, random forest, and multilinear regression. So since this session is actually only 1 hour long, we are not able to cover all the different machine learning algorithms that we have. However, I'm just going to show you how we can, some of those regressions that we have here, just so you can get an idea on some of them. For classification algorithms, we will start with logistic regression. Now, when it comes to kind of logistic Logistic regression is all about solving binary problems. So it's used to kind of calculate the probability of an event. Either the event will happen or not. So is it zero or is it one? You know. So it's actually used to predict binary outcomes. So, for example, is if a student is going to pass this exam or fail that exam, if this is if the patient has cancer or not, and so much more. For example, we obviously in 2019 we went through the era of COVID-19, so we can apply machine learning to determine if a person is likely to be infected with COVID-19 or not. So such a type of problem would use the logistic regression algorithm. And obviously, you can see logistic regression be used in several sectors. For example, in marketing, logistic regression can be used to predict if a targeted audience would respond to you or not. And this is the kind of graph for logistic regression and how it would kind of go. When it comes to naive Bayes, obviously it falls under the classification kind of algorithm. Naive Bayes is all about calculating the possibility of whether a data belongs within a certain category or not. Now, let's look at the example we have here in the table. So, we would kind of use a naive Bayes when you want, for example, in text analysis. So it can categorize words or phrases as belonging to a preset tag or classification or not. For example, when once the text you say it's a great game, the tag for that or like the category it falls under is sports, and then if it's a very clean match it falls under sports. If you say a bird is flying, this would be not sports. So this is an example of a text analysis kind of example used for naive Bayes. So it helps with deciding whether or not a phrase should be tagged as sports or not. And this is kind of the equation that you see here that is used for naive Bayes. Decision trees. With decision trees, it's all about, as you can see here in the sports example, this is how a decision tree works. So you have kind of like a tree trunk, a main tree trunk, and then you will have kind of be separated into kind of branches, and then kind of into underneath those branches it will be kind of divided into leaves. So this is where kind of the categories become more infinitely similar to each other, and it kind of creates categories within categories which allow for organic classification. For example, let's take the sports example. So based, you have a sports as the main kind of tree trunk. Based under that, the branches, you have racket sports and bat sports. And for example, racket sports fall underneath it. The leaves, you have ping pong, tennis, and racquetball. And bat sports, you have cricket or baseball. So this is kind of how a decision tree works. And for example, on the right here, you have, if you want to classify if a person is fit or unfit, then this is how a typical decision tree would look like, a very simple one. So you have the age, it will show the age, if they are less than 30 or more than 30, do they eat pizza or do they exercise, and so much more. And based on that, it will give you the outcome if that person is fit or unfit. Now let's look at the most common or most popular regression algorithms. So for regression algorithms, they are all about predicting a numerical value. Linear regression is one of the most commonly used algorithms in, obviously, regression problem. And linear regression is used to predict the value for dependent variables based on the values of independent variables. And the outcome in linear regression is actually continuous and can be any possible value. So it's very important to know it predicts the value of a continuous quantity. So here you have this kind of graph that shows the y and x, the y being the dependent variable and the x being the independent variable. And here you have the slope, which you have the data points around the slope, and you have the line of regression. And the regression line is the best fit line for the model. Our main objective in this kind of linear regression algorithm is to find the best fit line, just like you can see here. You have the random forest, which is part of the regression kind of algorithms and such. Random forest actually is a kind of, it looks familiar or similar to decision trees that we saw earlier, but however, it only uses multiple decision trees for predicting the output. And let's look at the example here, for example. So instead of having only a simple decision tree, you will have kind of multiple decision trees and multiple branches that fall underneath each, which help you kind of compute the final output that you can look for. And it's important to mention that random forest actually can be used on both regression tasks and also on classification tasks as well, not only in regression. And the last algorithm that we're going to look at today is the multilinear regression. So instead of only using one, obviously, type of linear regression, this is where you kind of estimate the relationship between two or more independent variables and one dependent variables. So where can you see multiple linear regression be used? You can be, as you can see it used, and for example, how rainfall, temperature, and the amount of fertilizer are added can affect the crop growth in the environment, and so much more. So basically, you have multiple, you want to find the relationship between two or more kind of independent variables and one dependent variable. For example, let's take an example here. So let's say you are a public health researcher and you are, you are interested in learning more about the social factors that kind of influence heart disease. So you will survey kind of 500, let's say, towns or people and gather data on the percentage of people in each town who smoke, and the percentage of people in each town who bike to work, and the percentage of people in each town who have heart disease. Because you have kind of two independent variables and one dependent variable, you can use multilinear regression to analyze the relationship between them. So this is where you see multilinear regression being used. And here we have kind of this is the graph or visual of how it could look like. You have the heart disease, you have the biking to work, and this is the rates of heart disease table or figure, which is shows the percentage of the population as a function of biking to work and smoking. So here we kind of calculated the percentage of people biking to work, and we calculated the predicted values of the dependent variable. And this kind of shows us the smoking constant at a minimum, a mean, and a maximum observed rate of smoking, as we can see the red, blue, and green line in the graph here. So this is the last kind of type of machine learning algorithm that we will see in the regression algorithm. However, there is so much more. This is the machine learning algorithm cheat sheet that I would like to obviously highlight, and I always love to use in these kind of sessions and show you, because it is very, very, very useful. It will make your life easier. So if you're getting started and you don't know where to begin, based on what you really want to do and what your goal is, this cheat sheet kind of helps you choose the best machine learning algorithm for your predictive analytics solution. And your decision is basically driven by both the nature of your data and the goal you want to achieve for your data. For example, what do you want to do? So today you want to predict values. You have a regression problem then. So underneath regression, we have different kind of algorithms that you have. So for example, you would use linear regression, which answer questions like how much or how many. For example, you want to classify images today. You want to do some image classification, and such. You would use the dense net algorithm that will help you classify images with popular networks. So this is just to kind of an overview. If you would like to see this poster, or you can either take a screenshot or you can go to the link underneath aka.ms/ml cheat sheet. So I highly recommend you to check this one out to help you get started in your machine learning algorithm learning kind of journey and such. Now we are kind of at the end of the session. So I always love to kind of give tips to people who are interested into getting into this field and really don't know how to actually get started into the field of AI. The best advice I can give to you is to start by knowing the foundational concepts and by building a framework of all the core concepts that you need to know. Your best bets and best guides are Microsoft Learn and the GitHub Microsoft kind of page that we have. So if you go on Microsoft Learn, you will actually see lots of learning paths and free learning modules, all free for you to use and to actually learn at your own pace from A to Z. And we have kind of different levels from beginner to advanced and even intermediate if you want, in different tech topics and tech fields that you could literally think of. So let's say you are looking to learning more about artificial intelligence, just go to Microsoft Learn and search artificial intelligence beginners, for example. You will find lots of learning material for you that's free for you to use. So after you built your foundational concepts from Microsoft Learn or from GitHub, you would need to kind of be familiar with learning a code a coding language. It's not important for you to be an expert, but it's very important for you to know the basics of how to use any coding language that you would kind of are interested in knowing more. So you have Python, you have R, you have Java, and you have so many more. But your best bet, if you're a beginner and you don't know where to begin, the easiest language or the easiest coding language for you to learn is Python, because it has lots of libraries that help you get started and understand and begin this journey. Then, after you have built your foundational concepts and you've learned your coding language, it's very important to start getting your hands on and starting working on hands-on projects. So try to find free data sets online. There's we live in a world where obviously we have free resources. So just Google, for example, I want a football data set, and start by actually looking at projects and take that data set, and based on what you've learned and the steps that you've learned, start by actually applying that. So because you never really learn except by actually starting to do it with your own hands. The last important thing that you want to do in order to get started in AI is, and I think is very important, is to connect yourself with an AI community. So you might be living in a country where you don't know how you can, kind of see where the available AI community there is around you. But we live in a world, thankfully, that is online. And obviously, the online community is actually absolutely huge. This is why I'm streaming online today, and I have people from all over the world joining me. So it's very important to connect yourself to an AI community to kind of network, share ideas, and learn from each other, and to even know about the more concepts and such. I'm just giving me a second. I am just copying it into the chat. And I am seeing, as I am actually typing this in, I am actually seeing more people that we have from all over the world. So let me. Here is the second link that I do highly, recommend for you to check out. It's a very useful learning resource. I would highly recommend for you to check it out. Let's check it out together. I will open it right now just to kind of. You can even scan them, by the way. I put the barcodes as well for you all to check them out. So this actually is a learning path, which is on Microsoft Learn. It's all about getting started with the AI with all the concepts that you have here. It shows how to start with AI on Microsoft Azure, the different kind of also key workloads that you have, understanding what machine learning is all about and how it all works. So it just kind of gives more details. And even what I love about this is it even talks about Microsoft Azure in more details. So obviously we have the Microsoft Azure cloud platform, and it talks about how you can use AI and machine learning and Microsoft Azure basically there to build your own solutions. So highly recommend these two links out. They are absolutely free for learning material and absolutely wonderful for you to use. So we are done for today. Thank you all so much for joining us. We are not done yet in this series. We have the last episode of this Jumpstart into AI series happening next week on Monday, January 30th at 4 p.m. GST. At the same time, so please join us to kind of as we take you on to the last episode of this series, so you can continue your learning journey and start by building your own AI project. I look forward to seeing you all there, and thank you all so much for joining us. I hope you kind of had a very lovely, enjoyable session. And that being said, we are done for today. Thank you all so much for joining us, and I will see you next Monday. Bye bye.